Okay, so in our previous video, we introduced reducing balance loans, and we used a recurrence relation to model that. And when we write it as a recurrence relation, we have both geometric growth, that's the compounding interest, and also linear decay, which is the repayment being made. Obviously, the recurrence relation's a bit limited. We cannot convert, when we've got those two things happening, we cannot convert that into a rule to enable us to straight away work out what's happening after 20 years. We're stuck with the recurrence relation, so we would have to recur 20 times. If it's a home loan with monthly repayments over 30 years, that's going to be 30 times 12 recurrences that we would need to make. So another way that we can represent these kind of loans is in something called an amortisation table, which is basically a table that very similar to one that I used without calling it an amortisation table in the previous video, where we essentially look at what happens at each payment, how much interest is added on, what repayment happens, etc., etc. And we can generate that information. So if we're any good at spreadsheeting, it's very easy, obviously, to set up the formulas and then generate the loan over a long period of time. Now, we don't have to make use of, you can make use of a spreadsheet in your CAS. It is not necessary and not really required. The types of questions you tend to deal with amortisation tables, they give you most of the table, and there's usually just a couple of blanks that you need to fill in. So it's not really about being able to generate the whole table, it's being able to understand and read what's happening in the table and perhaps calculate some missing amounts. Okay, so an amortisation table is a data table that shows the process of paying off a loan, and it contains details of each payment made and how that payment is divided to pay interest and also to reduce the principal value of the loan. And then it gives the balance of the loan at each stage. So each month the following steps occur. Okay, we have a current balance, we add interest, we subtract the payment, and then we have a new balance. That's basically what's going on. So when a payment's made, it's first used to pay off the interest that was added in that month, and then anything in excess of that is used to pay off the balance of the loan. Okay, so for example, in a month, let's say $200 of interest is added on, and you make a $300 monthly repayment. So $200 of that payment goes to paying off that interest, and then only $100 is actually coming off the balance of the loan, is essentially what we're looking at. Okay, so let's have a look at an example. $2,000 is borrowed at an interest rate of 6% per annum compounding monthly. The loan is to be repaid by making 12 monthly repayments of $172. Note that 6% per annum is 5% per month. Okay, so these are the columns you're going to have in your amortisation table. Okay, payment number, payment amount, interest paid, principal reduction, and the balance of the loan. I'm sorry, I skipped over that smaller table up above there, which illustrated that. So essentially your first row will be payment number 0, and you'll just put the principal value of the loan in the right hand column. That's the starting balance. Okay. Then at the first payment, it'll be your repayment amount at that first payment. You're going to, in this column, work out the interest that is paid at the first payment. So that's your your balance times the monthly interest rate, or times, sorry, not times the monthly interest rate. Yes, times the monthly interest rate. And then the principal reduction is going to be how much is actually coming off the balance of the loan. Okay, so thinking about the fact that your repayment amount is first used to repay the interest, so it will only be the difference between the repayment amount and the interest that's actually going to come off the loan. So you do repayment amount minus the interest, and then to work out the new balance, you take your previous balance and take off the principal reduction to get your next balance. Okay. Alright, so let's have a look at what's happening here. So you're starting with your $2,000 loan, okay. The payment is $172 every month, so we can see we've got $172 throughout the whole column here. The interest paid, so as I said, 6% per annum is 0.5% per month, which means we multiply by 0.005, that's 5%, okay? So we're not doing 1.005 because we're not working out the increase. What we're just calculating is the interest itself. So the interest on $2,000 is $10 in the first month, okay? And then we're working out how much we're going to reduce the principal amount by. So we're going to make a repayment of $172. $10 of that will go to just paying off that interest, okay? And then so the remaining $162 is actually going to come off the balance of the loan. And so our new balance then is $2,000 minus $162, okay? And then we repeat the process again. So now this is our new balance. We make a repayment of $172. We calculate the new interest, 0.5% of the previous month's balance, so $9.19 of interest in the second month. Again, that $9.19 of the $172 payment immediately goes to paying off that, and then the remaining amount, $162.81, is going to come off the balance of your loan, and now you've got your new balance. And we can continue that again for the third payment, and we find that the balance after 3 payments is now $1,511.57. Okay, so let's work out what happens at the fourth payment. So the interest paid is going to be 0.5%, so 0.005 times the previous month's balance, which is 1511.57, okay? And so we can work that out, 0.005 times 1511.57, and it is $7.56 to the nearest cent. So then the principal reduction is going to be the payment of $172 minus the $7.56, okay? So $172 minus $7.56, okay? Again, I probably could have, yeah, that's okay. You could use your previous answer rather than type in $7.56. So it's $164.44 that's actually coming off the balance of the loan. And so then we subtract that. So this is going to be 1511.57. So last month's balance minus the principal reduction, which is $164.44, sorry. So 1511.57 minus this principal reduction, which means we are at $1,347.13, and the process continues. So if we were to multiply that by 0.005, we now get our $6.74 at interest at the next month. Subtracting $6.74 from 172 gives us our principal reduction. Subtracting that from last month's balance means after 5 payments we're at $1,181.87. And we can continue the table until we get down to either 0, or you'll very rarely get exactly to 0, so there's always going to be that moment of adjusting your last payment. So we find that after 12 payments we actually still owe $1.65, okay? And so that means we would adjust the last payment, so we would add $1.65 onto the $172 and make our last payment $173.65. So total payments would be 11 payments of $172 plus 1 payment of $173.65 to make a total payments of $2,065.65. And so therefore the interest paid over these 12 months is $65.65. Okay, let's work through one example here. So this is the kind of thing you'll get. You won't have to generate the whole table yourself. There'll be some missing values. How can I work out the missing values? Okay, so a loan of $5,000, so that's our initial balance, charges interest of 8% per annum compounded quarterly. Okay, so 8% per annum compounded quarterly is therefore 8 divided by 4, so it's 2% per quarter. So every quarter we're multiplying by 0.02. Okay, every quarter. So that means to get the interest, you're going to take the previous balance and times by 0.02. Okay, I'm going to show this when you've got the table like this with just some missing values. There's always a number of different ways that you can find the missing amounts. So we'll talk about the different ways that we can do it. So and we're also making 4 quarterly repayments of $1,313, so they're already in the table, although you'll see there's an adjusted payment here. It's been adjusted so that the final balance is 0, so we're paying a little bit more, just so we get down to 0 at the end and we don't owe any money. Okay, so let's work out the value of A, so that's the interest at the first payment. So we can do that a couple of ways. We can obviously do it in the way it's sort of intended if we were generating the table ourselves, which is to work out, take the balance and work out the quarterly interest from that previous balance. So 5,000 times not 0.002, just 0.02. And so that is $100. Okay. The other way though that we could do it is we could see that actually the principal reduction, the payment was $1,313 and the principal reduction is only $1,213. So the other way we could do it would be to do 1,313 minus 1,213 to see that we've got a $100 reduction. So that's the way, because we know that to get this number here, we do this number minus this number, okay? And so therefore we can work out A by using that fact, okay? So either way, we can work out A to be $100. Okay, let's think about B. So B is the principal reduction at the second payment. So we know the principal reduction is the monthly payment minus the amount of interest paid in that month that you need to pay in that month, and then the remainder of the payment is going to go towards reducing the principal. So B is going to be the monthly repayment minus the interest for that month, so 1313 minus $75.74, and so it should be $1,237.26. The other way we could work out the principal reduction would be to work out the difference between the two balances, okay? Because that's what we take. The B, we subtract B from last month's balance to get this month's balance. And so therefore, we could also have done $3,787 minus $2,549.74 to work out what was the principal reduction from month 2 to month 3. Okay, let's just check that gives us the same. So 3,787 minus 2,549.74. We do indeed get the same amount. Okay. All right. So option C is the balance. So not option C. Finding the value for C is the balance after 3 months. And the easiest way to find the balance after 3 months would be to take the balance after 2 months, subtract the principal reduction to get C. So it's going to be 2549.74 minus the principal reduction of 1262.01. Okay, so 2549.74 minus 1262.01. And so the balance at C should be $1,287.73. We can also check that. We could work back from the interest at the next month, but that's the subtraction's definitely the easiest way. We can check that because if we work out the 2% of C, it should give us $25.75. So if we multiply that by 0.02, yeah, it gives us $25.75. So we can check that that's correct in two ways as well. And then finally, part D is to work out the total interest paid. So we can, a couple of ways, you can do this a couple of ways. You can work out your total payments and then subtract 5,000, but actually you can work out your total interest just by adding up your interest paid column. Okay, so we can work out D either by doing the total payments and subtracting 5,000, or by adding up. So A was 100, so it's going to be 100 plus $75.74 plus $50.99 plus $25.75. So you can see how that interest is decreasing from month to month, because as the balance decreases, 2% of a smaller balance is a smaller amount of interest. $75.74 plus $50.99 plus $25.75. So total interest is $252.48. As I said, you could also do it as total payments minus the principal, which would be, so our total payments is going to be, we make 3 payments of 1313 plus that last adjusted payment of 1313 and 48 cents. And then that's our total payments, and then we subtract the principal amount of 5,000, should give us the same thing. 3 times 1313 plus 1313.48, and then subtracting 5,000 also gives us $252.48. So there's always going to be more than one way to work through the amortisation table to find an unknown value, okay? But it's about understanding what those values are and how to find the required value that you need. Alright, so the work today is 2 questions from exercise 9B.